Hi, good morning everyone. This is Kanu Bhutani here and welcome back to my channel. Today we are again going to dive deep into the Pinecone embedding. What is Pinecone embedding? We are going to look. So the Pinecone embedding is not a specific type of embedding, rather it uses the vector embedding. So now what it is, that vector embedding? So embedding is a numerical representation of data in a high dimensional vector space. So for example, if you write, it's a numerical. So if you write I love pizza, this will get converted into high dimensional vector space like this, the numbering, into 1536 dimensional vector. It will convert this thing into, in which it has minus, plus, zero point 0.7, everything. And these vectors capture the semantic meaning. Like for example, if love is in minus 0.45, so similar, the word similar to love will also have minus 4.6, minus 4.7. So that similar text will have the similar embeddings and they will be close to each other. So now what is Pinecone? It is a managed vector database. It is used to store, search and retrieve the embedding vectors efficiently. So the way it is embedded, as I told you, that it will take, for some of the things, it will take plus sign, so plus 0.12, and for some it will take minus. So it will decide in on their own that for a specific, for pizza, what numbering it should be done, and similar numberings are done to get the similar embeddings for the similar texts. So now you can store the million of embeddings into it. You use either of the three, the cosine similarity, which we will see, which we use it very regularly, then dot product and Euclidean distance to find the most similar vectors. But here now we will see only cosine similarity, and then build the semantic search and recommendation engines or RAG systems, whatever we want to do. So then when we say Pinecone embedding, it is a process of storing and querying embeddings in Pinecone to perform similarity search or retrieval. So you understand this, that normally when what we do is that when we store some data, for example, I love pizza. So if the question is asked, does Kanu loves pizza? So it should say yes. It should not say no. And if the question is asked, does Kanu hates pizza? So the answer should come no. Kanu loves pizza. So for that, the embeddings are very important. So typically how it works is get embedding. It uses the models like OpenAI to convert the text into vectors. Then it stores in Pinecone with the text and ID. Then the query, it's converted the user input, which like Kanu loves pizza, question mark, that also will be converted into embedding, and then the similarities will search, will do the, okay, Kanu loves, okay, yes, loves pizza, yes, then it will give yes. But there, if I put Kanu hates pizza, so it will give no, hates, that is opposite of love. So no, Kanu does not hate pizza, he loves pizza. So that is the way we do it. And so the cosine similarity is over here. If you find here, what is cosine similarity? It will measure the similarity between two vectors, and that calculates the cosine angle between them. So the two vectors in same direction, it will give 1, two vectors in 90 degrees will give 0, and two vectors in opposite directions will give -1. So if you see here the formula, a dot b divided by a and b, the magnitude lengths. So it doesn't make any difference. Like for example, in cosine similarity, it will ignore the magnitude. It will not take the magnitude of the vectors, and in fact, it will only focus in the direction. So for example, I love dogs and I adore puppies. They both have different word lengths. So they have the different magnitudes of the vector, but it will still point in the similar semantic direction, because love and adore, they both are the same things but with different word lengths, and dogs and puppies are the same. So it will point in a similar semantic direction, then it will give us the reply that yes, Kanu love dogs or Kanu adore puppies, either of the two. So in this example, we'll say a equals 1 comma 2, b equals 2 comma 4, but the vectors have same direction. So cosine similarity of these two, which it is I love dogs, which is a, I adore puppies, which is b, both will have cosine similarity as 1, so they will be very similar. So that way it is done the cosine. And in case if I ask the question, I hate dogs, so hate will be negative. So the query which is asked, it will give negative -2. So it will point in a different direction, -1 direction. So they are not similar. So we will get the reply that no, Kanu doesn't hate dogs, but he loves dogs. So that is the entire explanation of the embedding in Pinecone, and I hope this is a good explanation. See, here also I have added here that when you convert the words like embedding, it will capture the meaning. So in music, it will capture in one direction. All the words will point in one direction, like song, melody, guitar, and IT will point in another direction, technology, software, computer. So they will not have the same direction. The cosine similarities will be different, so it will be low and it will not be similar. So if I say that I like music, so it will point into the direction of along entertainment axis, and IT will point along the technology axis. So these two will not be the same. They are not closely related to each other. Okay, so that explains that then the cosine similarity will be negative, and therefore it will give sorry. These two things are totally different. The music is totally different. The IT is totally different. So I hope you have understood a lot about the pinecone embedding and how it helps us to actually come to a result which is quite similar and which is quite correct. We'll get the correct answer to our question once we use this pinecone database. So thank you very much. I hope this really will help you understand and code accordingly. Bye.